Good evening, students. Today we will learn about the fuse. What is an electric fuse? It is a safety device which is used to limit the current in an electric circuit. The use of a fuse safeguards the circuit and the appliances connected in that circuit from being damaged. Now, in the earlier videos, we have seen that fuse helps us in stopping the current if excess current is flowing so that our appliances are saved. Now here in the figure you can see the fuse arrangement. The fuse is nothing but a short piece of wire which is made up of a material of high resistivity and low melting point, so that it may easily melt due to overheating when the excess current passes through it. And generally the wire is made up of an alloy of lead and tin. Now every fuse has got different rating depending on how much maximum current it will allow to flow. The copper wire we never use for as a fuse wire because the copper has very low resistivity, so high current will flow, and it has got high melting point also, means it will not melt also. So in what will happen, if high current flows and this wire doesn't melt, the connection will not be broken and the appliances will be damaged. Now let us see the construction. Now the fuse actually consists of two things. One is the fuse holder and one is the socket. Now the socket is fixed on the board, that is on the wall there is a board, and on that board this socket is fixed, and this holder fits into that, and you can also remove it out. You must have seen in the videos or in the movies or some serials they are removing the fuse, so how they pull it out. So this is that holder which they catch and they pull it out. Now this holder is made up of porcelain. The outer covering is made up of porcelain, which is a bad conductor of electricity, so that when you touch it and remove it out, you don't get the shock. Now you can see on the porcelain holder, you can see T1 and T2. The T1 and T2 are the two metallic terminals. These are made up of metal and they are the terminals T1 and T2. Now this holder, it fits into this particular socket, and this socket is also having two metallic terminals. You can see the live wire coming from the two terminals in the socket, blue color. Okay. So when you put this holder into the socket, then this terminal T1 and the terminal T2, it gets connected with these two terminals in the socket, and the circuit is completed. Now how does it work? Now whenever the current, whatever current is coming from the live wire, it is passing through this and entering your house. Now suppose due to some reason the current in the circuit exceeds some specific value, whatever rating you have done, then what happens? The fuse wire gets heated, and when the fuse wire gets heated, it melts. And so now you can see the fuse wire. Now see in the figure where they have written fuse wire. Now this wire is connecting terminal T1 and T2, but if the fuse wire will melt, the connection between T1 and T2 is gone. There is no connection now, it is broken, and the current will now no longer flow into that appliance, whatever is connected in your house. So now what we will do, we will remove the fault in the circuit, and a new fuse wire carrying the same current will be again fixed between the terminal T1 and T2. Fuse is always connected in the beginning of the circuit. Why? Because it is to safeguard the circuit. Before the current entering the appliance, the fuse is going to check it. If anything happens, if anything is to be damaged, the damage will be done to the fuse and not to the electrical appliance. Okay. Now let us see what happens and how the working is actually taking place, and when the fuse wire melts, what happens. Now you can see here in the picture, now we have put the socket, we have put the holder into the socket. Okay, the holder is going inside the socket. So what happens, this terminal T1 and T2, you can see they are entering into that gap, and they are made up of metal. So what happens now, the whatever connection is done because of the blue live wire, the current is now flowing into this terminal T1 and T2, and from T1 and T2 it is flowing into the fuse wire. Okay, now here in the figure you can see that the fuse wire is broken. Okay, so whenever the current exceeds that limit, this fuse wire breaks. Now what happens? The circuit is not completed. The circuit is broken and the current will not flow into that particular electrical appliance. So this is the figure of when the fuse is broken, when the fuse melts. And after fitting, this is how the circuit looks like. Now here with the same example, you can see figure A and B is there. In figure A, there is an appliance which is connected through a fuse. The live wire is going into the appliance with a fuse. When everything is fine, the current flows, the circuit is closed, appliance is working. In the B figure, due to some reason, excess of current, the fuse wire melts and the circuit is broken. It becomes an open circuit. Current is no longer flowing because there is no path for it to go from the point F to the appliance, and the connection to the appliance is cut and it is saved. Okay, so these are the two figures showing fuse in use and when the fuse wire melts, what happens. Now this is also one type of fuse. It is known as cartridge type fuse. You have got metal caps, you can see at both the ends, and there is a thin glass case, and inside the thin glass case there is one fuse wire which is soldered means joining with the help of a soldering gun. So it is joined at both the ends, and when the fuse wire melts, this is the fuse wire, it will melt and there will be no connection between the two metal caps. These kind of fuses are there in the inverter. You can see it behind your inverter.